is about solving problems on properties of solution and thermochemistry, specifically molality, boiling point elevation, and the first law of thermodynamics.
So let's start.
Molality is expressed as moles of solute divided by the mass of solvent in kilogram. The unit of molality is small letter m. Example number 1, calculate the molality of a solution containing 10.4 gram of naphthalene in 48.2 gram of benzene. So our solute here is the naphthalene and our solvent is the benzene. So in this case, to calculate the molality, I have 3 steps here. Step 1, determine the moles of naphthalene. So 10.4 gram of naphthalene times the molar mass of naphthalene, which is 128.18 grams per mole. This will be 0.081 mole of naphthalene. So since the mass of benzene is given but the problem is nasa gram siya, so you have to convert it into kilogram kasi required is kilogram. So 48.2 gram times 1 kilogram is equal to 1,000 gram, then cancel yung gram, then equal to 0.0482 kilogram of benzene. So step 3, get the molality. Since nakuha mo na yung mole of solute at saka yung kilogram ng solvent, i-plug in na sa formula. So 0.081 mole of naphthalene divided by 0.0482 kilogram of benzene, and it is equal to 1.7 molal. So the formula for boiling point elevation is delta T times K sub B times M times I. Delta T means the change in temperature from the pure solvent's boiling point to the boiling point of the solution. K sub B is the boiling point constant, and M is the molality of solution, and I is the Van Hoff factor. It is a unitless constant directly associated with the degree of dissociation of the solute in the solvent. Example number 2, it's about boiling point elevation. So the question is, what is the new boiling point of a solution prepared by adding 35.0 gram of menthol to 0.0221 kilogram of chloroform? So note that the boiling point of pure chloroform is 61.2 degrees Celsius and the boiling point constant of chloroform is 3.85 degrees Celsius per molal. So ibig sabihin yung pure boiling point ng pure chloroform is mas tataas pa dyan. So to get the new boiling point of a solution, step 1, determine the molality of menthol solution. So 35.0 gram of menthol times the molar mass of the menthol, which is 156.3 grams. Then cancel yung grams. Then it will be 0.22 moles of menthol. So nakuha mo na yung moles, diretso ka na sa calculation ng molality. So since given yung kilogram of chloroform, so i-plug in na sa formula ng molality. So 0.22 moles of menthol divided by 0.0221 of chloroform. So this will become 9.95 molal. So step 2, utilize the boiling point elevation formula. Delta T is equal to K sub B times M times I. So Kb, the boiling point constant of chloroform, is 3.85 degrees Celsius per M, which is molal, times 9.95 molal times 1. And then this will become 38.3 degrees Celsius. 38.3 degrees Celsius is not our final answer. So the question is, what is the new boiling point of a solution? So ano yung boiling point of pure chloroform? This is 61.2 degrees Celsius. So ibig sabihin, i-add natin yung nakuha nating boiling point, which is 38.3 degrees Celsius. Pag nag-add mo yan, magiging 99.5 degrees Celsius. So ibig sabihin, therefore, the new boiling point of a chloroform is 99.5 degrees Celsius. The first law of thermodynamics gives the relationship between heat transfer, work done, and the change in internal energy of a system. These three are known thermovariables of this law. 1,800 joule of heat energy was removed from a gas. The gas was compressed at a constant pressure of 2.08 atm from 20 liters to 10 liters. How much work was performed by the gas or on the gas? Calculate the change in the internal energy of a system. To start the calculation, step 1, identify the heat. So our heat here is negative 1,800 joule. Bakit negative? Kasi na-remove siya sa gas, so naging negative. Step 2, calculate the work done and identify whether it is done by the system or on the system. Work done is equal to pressure times change in volume. So 2 atm times 10 liters minus 20 liters is equal to negative 20 LATM. So convert natin yung LATM to joule. So bale magiging negative 2,226 joule. So ang result is negatives, means that the work is done on the system. So step 3, calculation on the change in internal energy. So A delta U is equal to Q minus W. So our Q is negative 1,800 joule minus negative 2,026 joule. So this will be positive 226 joule. So that's the change in internal energy. I hope you all understand. By the way, this is Ansari from stand 12.